We've known for years that our species wasn't alone. Neanderthals ranged across Europe and the Middle East, Homo floresiensis clung to its island home in the tropics, and somewhere across the vast stretches of Ice Age Asia, there were the Denisovans. We have a few fragments of their bones and have identified their DNA in billions alive today. But for more than a decade, they remained little more than a name. But now, scientists have finally put a face to that name. And the more we uncover, the stranger their story becomes. What kind of world did they inhabit, and who else did they encounter? Could they have survived longer than we think, perhaps even past the Ice Age? And were they giants, as some have claimed? Today, we're going to explore what we know and what we don't know, and why the Denisovans remain one of the greatest mysteries in all of human evolution. In 2010, a tiny fragment of a pinky bone found deep in a frozen cave changed everything. At first, scientists thought it might belong to a Neanderthal, but when they tested the DNA, the results were astonishing. This was something else entirely, a previously unknown branch of the human family tree. They called them the Denisovans, after the place where the bone was found, Denisova Cave, high in the Altai Mountains of Siberia. 2 years later, another bone fragment was tested. It was found to belong to a young girl. Her mother was a Neanderthal and her father a Denisovan. To date, this is the only first-generation hybrid hominin ever discovered. For hundreds of thousands of years, this cave served as a crossroads for ancient humans. And the artifacts, they are astonishing. Bracelets of polished stone, drilled with tiny holes, the work of delicate hands. They made advanced stone tools and symbolic objects. These were no primitive people. They had culture and perhaps something approaching art. But here's the real mystery. Beyond this single cave, the Denisovans seem to vanish. For more than a decade after the discovery of Denisovan DNA, no one had uncovered any remains other than fragments. How could a people so widespread, whose DNA survives in millions of us today, leave behind so little? But then came an announcement that turned heads. In 2021, Chinese researchers unveiled a stunning fossil. A massive skull unearthed near the Songhua River in Harbin, northeastern China. The Harbin cranium. It was named Homo longi, or the Dragon Man. The story of this skull is nearly as strange as its owners. First discovered by a laborer in the 1930s during bridge construction, the fossil was hidden for decades, stashed away in private hands to avoid the destruction of the Second World War. It remained unknown to science for nearly 90 years. When it resurfaced, modern CT scanning and dating revealed a treasure. The skull is astonishing, one of the best preserved archaic human fossils ever found in East Asia. It dates roughly to 146,000 years ago, which aligns with when Denisovans are believed to have ranged across China and Southeast Asia. The brain case was enormous, around 1,420 cubic centimeters. This is within the range of Neanderthals and even exceeds most modern humans. In fact, it's about 10% larger than the average modern human brain today. But size alone doesn't tell the story. What makes the Harbin cranium remarkable are its features. It has a unique combination of traits seen in both Neanderthals and earlier Asian archaic humans. It has massive brow ridges, even more prominent than Neanderthals. It also has a broad face that is more flattened than Neanderthals or Homo sapiens. They would have had a huge nose, adapted for cold, dry climates. They had large, thick molars, a Denisovan trait suggested by DNA work. Their skull was low and long, and they didn't have a chin. This is typical of Neanderthals and other hominids, but unlike Homo sapiens. In some ways, the Harbin skull bridges a gap. It shares similarities with other East Asian archaic fossils like the Dali skull from northern China and the mysterious Solo skulls from Java. Yet it also resembles Neanderthals in robustness. Compared to modern humans, the differences are striking. And yet, the skull is not primitive. The brain size alone suggests advanced cognition. Combined with the tool use and the technology from Denisova Cave, it hints at a complex, adaptable human. But was it Denisovan? At first, the Harbin skull was cautiously classified as Homo longi, a new species created just for the skull. But as more data emerged, a new picture formed. It was found that the Harbin skull morphology closely matched the Zahi mandible, the Denisovan jawbone from Tibet. This was confirmed through ancient proteins and morphological traits. In 2019, Genetic studies revealed that there were multiple Denisovan populations, and it was thought that the Harbin skull likely belonged to an East Asian branch. Finally, in June of 2025, a breakthrough study by geneticist Kwame Fu and her colleagues finally provided the most direct evidence yet. They extracted mitochondrial DNA and ancient proteins from dental calculus from the single remaining tooth in the Harbin skull, and what they found was stunning. Even after excluding contaminated samples, the remaining ancient DNA clustered closely with known Denisovans from southern Siberia. It contained 27 gene variants found exclusively in all 7 previously sequenced Denisovan individuals. That alone would be compelling, but the protein analysis told the same story, a Denisovan signature preserved for nearly 150,000 years. But there was some controversy. Another Chinese paleoanthropologist not affiliated with the genetic analysis raised concerns that modern contamination may have skewed the results. And the researchers did find modern DNA in the samples, but Fu's team followed rigorous protocols to isolate authentic ancient fragments, and what remained was unmistakable. As of 2025, the Harbin skull is no longer just a strong candidate. It is the first Denisovan skull confirmed through both protein and genetic analysis. For the first time, we have both the face and the molecular signature of a Denisovan. This will help researchers analyze hominid skulls from the region and compare their similarities to the Harbin skull. This isn't just a fossil, it's a turning point in the story of human evolution. It proves that Denisovans weren't limited to the shadows of Siberia. They were far-reaching and genetically diverse, and they spread across East Asia in ways we've only just begun to understand. To most people, the story of human evolution is linear. We gradually evolved from primitive apes, advancing into our modern forms. While this is partly true, the reality is far richer and far stranger. We actually share a common ancestor with Neanderthals and Denisovans. Think of it like a family. Our grandparents were our last common ancestor, and Neanderthals and Denisovans were like our cousins. We didn't evolve from them, we just have a common origin. The common ancestor of modern humans, Neanderthals, and Denisovans likely lived between 600 and 800,000 years ago. Sometime after that, the Neanderthal-Denisovan lineage split off from the branch that would become Homo sapiens. And then perhaps 400 to 450,000 years ago, the Neanderthals and Denisovans themselves diverged. Neanderthals spread west into Europe and parts of Central Asia. The Denisovans moved east into the vastness of Asia. And here, they did something extraordinary. They adapted to an astonishing variety of environments. Think of how diverse Asia is, from the icy plateaus of Tibet, the fertile valleys of northern China, and the tropical islands of the southeast. The Denisovans had to be truly adaptable people to survive in all these environments. They would have come across the largest mammals of all time, Paleoloxodon namidicus. These beasts were over 3 times the weight of the largest elephants alive today. Another animal they undoubtedly met was Gigantopithecus, the largest ape to ever exist. Imagine the encounters these people may have had with them. Did they hide amongst the behemoths when the tigers were near, or did they even prey on young Gigantopithecus while their parents were distracted? The picture that forms of the Denisovan world is breathtaking. An entire continent populated by a people we still know so little about. Denisovans had large skulls, and in many ways they would have resembled Neanderthals. They were stocky and muscular, suited to harsh Ice Age climates. But they also had their own unique traits, such as flatter faces and massive teeth. As briefly mentioned, Denisovans themselves were also quite genetically diverse. There were at least 2, probably 3 distinct Denisovan populations. One, the Altai Denisovans, whose DNA came from that first pinky bone in Siberia. Another, more southerly branch whose genes appear in modern populations of Papua New Guinea, Australia, and parts of Southeast Asia. And now, with the Harbin skull, an East Asian population, morphologically distinct but clearly Denisovan. This tells us something important. Denisovans were not a tiny, isolated tribe. They were an expansive, complex, multi-regional population, as widespread in Asia as Neanderthals were in Europe. And culturally, they were also quite developed. Artifacts from Denisova Cave show advanced stone tools, symbolic objects, and even jewelry. And while these finds are stunning, we can't say for sure who made them. Modern humans were also in the region at the time, but the legacy of the Denisovans goes deeper. Some of their genes still shape us today. When Homo sapiens began leaving Africa sometime between 55,000 and 70,000 years ago, they didn't find an empty world. The continents were already home to other humans, and when we met them, we didn't just compete and fight, we bred with them. In some ways, we absorbed them, and their genes still live on in us. Today, nearly all non-African populations carry a small percentage of Neanderthal DNA. I have a little less than 2% myself. But Denisovan DNA tells us a different story. It isn't equally spread across the globe. If your ancestors are from Europe, you likely carry little to no Denisovan DNA. But if your ancestry traces to places like Papua New Guinea, Aboriginal Australia, and parts of Southeast Asia or the Philippines, the story changes dramatically. Geneticists have now shown that there's not just one kind of Denisovan DNA. Where did these encounters happen? The evidence suggests multiple waves. One likely occurred as Homo sapiens pushed east through Asia, from Siberia into China and beyond. Another occurred further south as they expanded throughout island Southeast Asia. Genetic modeling suggests that this southern encounter may have happened between 45,000 to 55,000 years ago, right when Homo sapiens first reached these new lands. Even more curiously, long isolated populations like the Andamanese Islanders show almost no Denisovan DNA. This tells us that these breeding events weren't global, they were one-time events. Specific populations met specific Denisovans, and the legacy of these encounters still lives in us. And some of these Denisovan genes undoubtedly shaped the survival of the populations in the area. In Tibetans, the EPAS1 gene, which comes from Denisovans, helps the Tibetan highlanders thrive where others gasp for air. That's not just ancient history, that's an inherited trait from those who walked the land over 50,000 years ago. Other genes influence smaller and more nuanced things such as immune responses, fat metabolism, and even skeletal structure. And once again, unlike Neanderthal DNA, Denisovan DNA is patchy and varied. East Asians carry some, but in Oceania, such as Papuans, Aboriginal Australians, and some islanders, the Denisovan contribution is huge, up to 4 to 6% of their genome. In 2024, a study found that people living at different elevations in Papua New Guinea also have differing levels and types of Denisovan DNA. In the lowlands, New Guineans inherited traits that help their immune system, and in the highlands, they have gene variants for early brain development. This study also suggests something fascinating. Denisovans may have crossed the Wallace Line. The Wallace Line is a boundary that separates the distinctly different animal species of Asia and Australasia. We know that Homo floresiensis was somehow able to cross this line, and it is possible that Denisovans did as well. If this could be proven with fossil evidence, the range of the Denisovans could expand significantly. It would also mean they were capable of crossing large bodies of water. Overall, the DNA evidence tells a fascinating story. This suggests that there may have been a substantial population of Denisovans living in Southeast Asia, despite little fossil and archaeological evidence to support this. But it proves that Denisovans were a major human lineage, a cousin species that thrived for thousands of years. They weren't some minor side branch of the human family. In many ways, they were the Neanderthals of Asia, and that's a nickname I think I'm going to keep calling them. Every mystery begs another question, and in the case of the Denisovans, one of the most tantalizing is, how long did they survive? Could they have seen the end of the Ice Age on some hidden mountaintop or island refuge? The youngest Denisovan fossils from Denisova cave date to around 50,000 years ago. But again, that's just one cave in Siberia, one of the coldest and harshest parts of their range. It tells us almost nothing about how long they might have endured in warmer, richer lands. You gotta think, what about northern China, the forests of Vietnam, or deep into Oceania? A 2019 genetic study found compelling evidence that Denisovans may have survived for far longer than anyone thought possible. As the paper says, the late date for the D1 integration and geographic structure in modern populations suggests that Denisovans survived until 30,000 years ago, and perhaps as recently as 14,500 years ago. This is absolutely mind-blowing, especially when you consider that the Neanderthals probably went extinct around 38,000 years ago. If the Denisovans survived until 14,500 years ago, they would have almost seen the end of the last glacial period, and it would make them the latest surviving archaic species that we know of. But here's where the mystery deepens. The fossil record of island Southeast Asia is fragmentary at best. Thick rainforests prevent excavation, acidic soils quickly destroy bone, and the rising of the ocean covers up a lot of previous Denisovan territory. There is no doubt that there are huge gaps in our knowledge about the Denisovans, especially in this region. And where the fossils are missing, the DNA speaks louder than ever. Again, some of the highest levels of Denisovan ancestry are found in Southeast Asia. And to reach these regions, Homo sapiens would have had to move through Indonesia, most likely meeting Denisovans along the way. And even within the expansive island of Papua New Guinea, different groups carry different amounts of Denisovan DNA, and that suggests that some populations would have had more recent contact with Denisovans than others. Could small Denisovan populations clung to survival on remote islands? It's very possible. Folklore from many island cultures tells of encounters with mysterious other people, beings larger, stronger, or stranger than the newcomers from distant lands. Could these be the distant echoes of Denisovans? Of course, folklore is not evidence, but combined with genetic clues and the massive gaps in the island fossil record, the possibility remains tantalizing. And since the archaeology is so young in the region and it's so difficult to excavate in many of these areas, we will undoubtedly come across some amazing finds in the next few decades. It is entirely possible that Denisovans survived for thousands of years longer than we currently know, maybe even brushing up against the edges of history. And until we dig deeper, we won't know. But one thing is for certain, the Denisovan story isn't over. In fact, it may be just getting started. With any mystery such as the Denisovans where there's legitimately a lot of things we don't know, myth usually makes it into pop culture. And when it comes to Denisovans, one myth just refuses to die. Spend a little time online and you'll see it. Denisovans were giants. They were 8 feet tall. They were rulers of lost advanced civilizations. Some even claim that they crossed the oceans, possibly founding America's mound-building cultures. You know, it sounds exciting, but is there any truth to these claims? Let's dive into the science. Firstly, the Harbin cranium is legitimately very large. Its brain case measures around 1,420 cubic centimeters. Pretty huge. But this doesn't mean this individual was giant. A big skull does not equal a towering body. Consider Neanderthals. Some Neanderthal skulls exceed 1,600 to 1,800 cubic centimeters in volume, meaning they had a far larger brain than the Dragon Man. Yet the average Neanderthal male stood about 5'5" or 165 centimeters. They were stocky and robust, but not giant. And Denisovans, based on what we know from Harbin, Zahi, and other fossils, their body proportions were likely similar to Neanderthals, shorter, powerfully built, adapted to cold climates and rugged environments. Their large molars and broad faces were likely adaptations for processing tough, fibrous foods. Simply claiming they were giant solely based on their molar size makes no sense. Another hominid known as Paranthropus had massive jaws and monstrous molars, but we know for a fact that they were pretty small. Males were barely 5 feet tall, 156 centimeters, and only weighed about 135 pounds, or 62 kilograms. This example goes to show you how misleading fossils can be when taken out of context. When you see claims that the Denisovans were giants, these people are misleading you. We currently do not have any evidence to prove this. In all likelihood, they were around the same size as their closest relatives, the Neanderthals. So where did the giant idea come from? Well, part of it's human imagination. Where there are gaps in the fossil record, people tend to fill them in with myths. And part of it comes from the 19th century giant skeleton reports, many of which were exaggerations, hoaxes, or misidentifications. Back then, it wasn't uncommon for old newspapers to sensationalize the discovery of unusually large Native American remains, often the result of mismeasured bones, tall individuals, or ceremonial burials. Some fringe theorists later linked these old stories to Denisovans, despite there being no Denisovan fossils in the Americas, no archaeological evidence that Denisovans ever set foot in the New World, and no DNA evidence suggests a direct Denisovan population in the Americas. While Native Americans do carry some Denisovan DNA, these low levels come from ancient interbreeding in Asia, long before their ancestors crossed into the Americas. Now let's be fair, it would be amazing if we found evidence of ancient human giants. Imagine digging up an 8-foot-tall Ice Age human, chasing down mammoths and fighting cave bears. But the real story of the Denisovans is just as interesting without all the myths. Think of it, they are a lineage that diverged hundreds of thousands of years ago. They were widespread across most of Asia, and they survived these lands and even passed down some extremely helpful genes that modern humans still enjoy. That's the true story, and in many ways, it's even more fascinating than the legends of giants. Because they weren't monsters or myths, they were people, human cousins who walked this earth long before we even left Africa, and whose story we're only beginning to uncover. If you found this video interesting, I got more videos just like it, unpacking the hidden stories of early humans, one mystery at a time. So subscribe, comment what you want to see next, and hit that like button as hard as a Jack Denisovan. And if you want more, YouTube thinks you'll watch this video,